The next rule we want to talk about when we're talking about exponents is called the power rule. And the power rule states that if you have a base raised to a power and then you have a parentheses and you have another power on the outside, to calculate your final answer, you take your power on the inside times the power on the outside. So that's the power to power rule. So for example, if we've got y to the 4 raised to the 2 power, that would be y to the 4 times 2, which would be y to the 8. Okay? So now let's try another one. If we've got a 5 squared and then raised to the 3rd power, 5 to the 2 times 3, which would be 5 to the 6th power. And if we want to work that out, that's something you could pull your calculator out for. 5 raised to the 6th power, that equals 15,625. All right, now in this next example, I have C's in the parentheses. So this is kind of a combination of a couple of rules, because I have a multiplication rule on the inside of the parentheses, so I can add these exponents on the inside and then take the power to power. And that's generally what I like to do if I've got parentheses. I like to simplify my parentheses on the inside first and then use the power to power rule. So I'm going to simplify my parentheses. C squared and then c to the 7th, 2 plus 7, so I'm taking 2 plus 7, so that's going to give me c to the 9th, and then I'm still got it to the 3rd power on the outside. Now I'm going to take it to the 9 times 3, so c to the 9 times 3 would be c to the 27. And it's just as easy as that. So when raising a power to a power, the exponents are multiplied. All right, let's look at some more examples. Here you can see you've got n cubed n to the 5th to the 4th power. So 3 plus 5 would be 8 to the 4th power, and 8 times 4 is 32. So that one works very similar to the one we just did above it. Let's look at the next one that we've got down here in the bottom. So I've got a d to the 4th, d cubed, and then all raised to the 3rd power. So I'm going to do the inside of the parentheses first. d 4 plus 3 would give me 7, so I've got d to the 7th to the 3rd power, and then d to the 7 times 3, so that equals d to the 21. Okay, so now we've got the properties. Now I'm going to have somewhere I don't necessarily have the same base in the parentheses. I've got different bases in the parentheses. And the thing you need to remember is that any term in a parentheses gets raised to the outside power. So a lot of times what I'll say in class is that anything in parentheses gets that power. So if you have an AB to the m power, that means A gets the m power, B gets the m power, whether they're variables or numbers. If you have an A over B and they're still both to the m power, then that's still an A to the m power over a B to the m power. So they both get that exponent. So let's do some with some actual numbers and variables. So negative 3abc squared. So that means I've got negative 3 that I need to square, an A I need to square, a B I need to square, and a C I need to square. So the only thing really to work out now is negative 3 squared would be negative 3 times negative 3. So that gives me positive 9. A squared, B squared, C squared. Just like that. Alright, this next one, we're going to do the same thing. Don't have to worry about negatives on it. So 2 to the 4th power. Now, each exponent on the inside of the parentheses gets multiplied times the one on the outside. So 3 times 4 would be 12. And then for my D, 8 times 4 is 32. So then figure out what 2 to the 4th is, and that should be 16. C to the 12, D to the 32. Alright, the next one is a fraction, and fractions should not worry you at all. That's just going to be 3 to the 4 over 2 to the 4th. And then if you figure out both of those numbers, 3 to the 4th power is going to be equal to, I believe it's 64, I think. Nope, 81. I'm thinking about 2 to the 4th power is my 16. And then if that could reduce at all, you would reduce it, but 81 over 16 doesn't reduce. Now on this next one, the 1 gets the 3rd power. That's really going to stay a 1 when I simplify it in just a second. And then on the bottom, I'm going to have 5 to the 3rd power. A, there's an imaginary 1 with that A, so 1 times 3 is 3. B, I have a 7 times 3, which would be 21. So when I simplify that, 1 cubed is just 1. 5 cubed is 125, that's on the denominator, and then an A cubed and a B to the 21. Not so bad. Okay, let's do these two examples at the bottom. They look kind of hard, but they're not really hard if you just take them a chunk at a time. So 3 to the 4th, m to the 5 times 4 would be 20, n to the 2 times 4 would be 8. So 3 to the 4th power, I think we just did 3 to the 4th power just above there and got it 81, m to the 20th, n to the 8th. Be sure you multiply your exponents when you have power to a power. Alright, this next one, I'm going to work it quietly. I want you to work it on your paper and then look back at the video and see if you get the same answer. Okay, hopefully you took the 3rd power that's on the outside with everything that's on the inside, so 2 cubed, we'll figure that out in a second. On the denominator, I'm going to have 3 cubed. R to the 3 times 3 is 9. S to the 5 times 3 is 15. So 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 3 times 3 times 3, which is 27. R to the 9th, and then S to the 15th on the bottom. Alright, let's move right along. Here's some that looks like a lot of fun. These look like just little puzzles to me. A lot of times when we're working exponents like this and we have multiple exponents going over and over, they just seem like puzzles to me. So I enjoy them quite a bit. We're probably not going to work a lot of these next ones. We're going to work, I'll just pick and choose so that the video is not just abnormally long. But let's just take it a chunk at a time. Here I've got a z to the 4th and it's to the 3rd power. So I'm going to take that as z. 4 times 3 would be 12. Then I still have a z to the 5th on top. So now I'm going to go back to my multiplication rule in a second. In the denominator, I've got z to the 7th squared, so 7 times 2 would be 14. Okay, now simplify the top. 12 plus 5, this time I'm having to add because these are multiplied. So 12 plus 5 gives me 17, and I have 14 on the bottom. And then do you remember what happens to exponents when you divide? Hoping that you said you subtract in your head. 17 minus 14 would give me 3. So z, that's a messy looking 3. I'm going to erase it and make it a nice looking 3. Z cubed. Alright, let's do this next one because I think you're going to see some like these in homework. This is one where we've got two things that are multiplied. I like to take each parentheses and simplify it as far as it'll go first before we start doing any multiplying. So since they have powers on the outside of each parentheses, I need to take care of those first. So in this first one, we're going to have a 5 cubed. We're going to have an m. 4 times 3 would be 12. And we're going to have an n. 1 times 3 is 3. So we're going to have that multiplied by negative 3 is going to get squared. We're going to have an m that's going to get squared, and an n that's going to be to the 4th power because 2 times 2 is 4. Now I can do my multiplying, and remember I can multiply the two numbers. I need to go ahead and simplify these big numbers though first. So 5 times 5 times 5, that's 125. M to the 12, n cubed. Let's do that. And then negative 3 squared is negative 3 times negative 3, which would be 9, m squared into the fourth. Now I can do the multiplying. So first I'm going to take 125 times my 9. That's going to give me 1125. So 1,125. Now for my exponents, I need to add because now I'm multiplying. So when you multiply, you add exponents. So 12 plus 2 gives me 14 on my m. On my n, I have a 3 plus a 4, which gives me a 7. Looks kind of difficult at the beginning, but if you chunk it, it's not so bad. Okay, let's do this one at the bottom. And it's going to be n squared to the fourth power, so I'm going to simplify that first. 2 times 4 is 8. And then in this parentheses, I'm going to have a 2 cubed, and I'm going to have an n cubed. Take care of that in a minute. On the bottom, in the denominator, I've got 5 times 2, so that'll be an n to the 10. So in the numerator, 2 cubed is going to give me 8. And then I've got an n to the 8th and an n cubed. That's going to give me n to the, oops, it's going to give me n to the 11. 8 plus 3. And then on the bottom, in the denominator, I've got n to the 10. So here I've got 8 on top, and then now I need to subtract these. 11 minus 10 gives me 1. So it's an 8n to the 1, or you can just write 8n, and that takes care of it. You don't have to write that 1. Okay, let's do one more. This one looks like a fun one. It's going to have lots of exponents involved. So you just have to be sure that you write down everything and that you don't try to skip a step. So I'm going to first of all take everything to the second power that's outside, because there are no, well, we have some options. We could do some subtraction on these and simplify them that way and then do the power. I tend to like to get my power out of the way first, and then I'll do some combining and do the subtraction. So because you never know what's going to happen with the numbers. So 6 squared, and then 2 times 2 for my a's gives me 4. 6 times 2 gives me 12 for my b's, and for my z, 10 times 2 gives me 20. In the numerator, in the denominator, I'm going to have 4 squared, and then a, there's a 1 there with that a, so 1 times 2 would be 2. For my b, 5 times 2 would give me 10, and for my z, 3 times 2 would give me 6. So now that's going to be, I'm going to go ahead and do the numbers. 6 times 6 is 36. 4 times 4 is 16. That'll reduce in a second. We'll go ahead and do the a's, and we'll do the subtraction. 4 over 2, so that would be 4 minus 2 would give me a squared. 12 minus 10 would give me a b squared. And then for my z, 20 minus 6 gives me 14. So the only thing I can do now is reduce the 36 over 16. 4 goes into 36 9 times, and 4 goes into 16 4 times. So I'm going to divide by 4s. So then I'll go 9 times, and then I'll go 4 times. So I have 9 a squared b squared z to the 14th over 4. So I'll leave that last example for you to work. You have another example down at the bottom. But that's pretty much how we take care of powers to powers. Y'all have a great day.